Hello everyone, welcome back to my channel MathMantis. In this question, we have been given a quarter circle. There is a circle of small radius r passing through the center of this quarter circle. And this circle of small radius r is touching two circles of equal radius capital R externally. And these two circles of equal radius capital R, they are also touching each other externally. And these two circles are touching this quarter circle internally. So we have to find the ratio of capital R by small r. So this is our question. Now to solve this question, we will start with the smaller radius r circle. So for this circle, we can say that since this is the point of the center of quarter circle, so there must be an angle of 90 degree here. And if I will consider these 2 points at which it is intersecting the quarter circle, so the line joining these 2 points will be the diameter of this quarter circle, because on the circumference the angle is 90 degree. So the center of this smaller radius r will be on this line. From this diagram we can say that. Now let's move on to this point, the point of touching of these two circles of equal radius. By symmetry we can say that the line joining the center of quarter circle and this point of contact of these two circles of equal radius, it will pass through the center of this circle. That is just by symmetry. Since these circles are of equal radius, so this portion here and this portion here, that will be symmetric, and that symmetry we can see from this diagram here. So this center will lie upon the line joining the center of this quarter circle and point of contact of these two circles of capital R radius. And even we can say that this line will be the common tangent of these two circles of radius capital R. Now since this line is the common tangent of these two circles, so let me draw the center of this circle and draw the line joining this point, and this angle must be 90 degree. And from the center of this circle, if I will draw a line joining this point of contact, the angle is 90 degree. That is the property of tangent. But this line is also tangent to this circle. So this is the point of contact. If I will join here, so this angle will also be 90 degree. And same is the case here. This is the point of contact. If I will join here, the angle is also 90 degree. But we can also see that this is the length of tangents drawn from the external point to this circle. So these two lengths must be equal, and these two lengths will also be equal because they are the length of external tangents drawn from the external point to this circle. So these three lengths will be equal. So now let me make 4 triangles here joining this point with these two center of circles also. So there are these 4 triangles. In these 4 triangles, if you will see this triangle, this triangle, this triangle and this triangle, all these triangles are congruent because this is the length of common tangent was there. This is the length which is same in all the triangles. Radius is also capital R and the angle is 90 degree. So these all 4 triangles are congruent, based upon which we can say that this angle, that is 90 degree, will be divided equally into 4 parts. These all angles will be equal in all these 4 triangles. So each angle will be 90 degree divided by 4. That is pi by 8 or pi by 2 by 4. That is 22.5 degree. So now let us move back to the original diagram here. So now we know that this angle is 90 degree. We have used this property of this common tangent of these two circles from this diagram. So now let me define these points as O, A, B and C. So from this diagram I know this angle, so I have to use this angle in terms of capital R. I can define length OB by using trigonometry in this triangle OBC. So from the trigonometry we can say that OB will be equal to BC divided by 10 pi by 8, or we can say BC divided by OB is equal to 10 pi by 8. From there we can find OB in terms of BC, because BC we know the value, that is capital R. So we are trying to represent all the lengths in terms of capital R and small r. So this value can be written as R upon 10 pi by 8. Now you must know the value of tan 22.5 degree, that is root 2 minus 1. So it can be written like this, and even we can rationalize this by root 2 plus 1 and root 2 plus 1. In the denominator we will get a minus b a plus b, that is root 2 square minus 1 square, that is 2 minus 1, that is 1. So OB length is root 2 plus 1 multiplied by r, that is this length. Now in length OB also we can see that OA length is nothing but the radius of the small circle. So from here we can define the length AB. Now why we are defining length AB? Because we will use that length in another triangle. Let's see how we do that. So now AB length can be defined as, that is OB minus R, or we can say that OB is nothing but R plus AB, that is root 2 plus 1 multiplied by capital R. So AB is root 2 plus 1 multiplied by capital R minus small r. So this is the length we have found. Now I will use this length AB to define one more triangle. How do we do that? Because till now we have used the property of touching of these two circles. This is the common tangent. We have not used the property of touching of these two circles. We know that we can join their center and we can define a line AC. The length of AC will be the sum of radius of these two circles, small r plus capital R, because they are touching each other externally. So from here I have defined a triangle using the length AB. So in this triangle of 90 degree I can use Pythagoras theorem, because I don't know this angle. If I have known this angle, I have used simple trigonometry. In this case I will use Pythagoras theorem to write the result, that is AB square plus capital R square is equal to small r plus capital R whole square. Now we will simplify this. This is a plus b whole square, capital R square plus small r square plus 2 multiplied by small r capital R. Now in this case capital R square will get cancelled out. So AB square is small r square plus 2 times of small r multiplied by capital R. Now I will define AB square, that is this whole square. So from here I will use the property A minus B whole square. So it will become A square, that is root 2 plus 1 whole square multiplied by R square, that is the square of this term. Then I will square this term, that is small r square. Then is minus 2AB, minus 2 times of root 2 plus 1 multiplied by capital R multiplied by small r. Now in the next step, if you will take a look at the left side and right side, here is r square, here is r square, we can cancel out both the sides. And here we can see capital R, and here also capital R, here also capital R square. So we can cancel capital R also from all the sides. That is, we have divided all the side by capital R. Now we will simplify this. So this is root 2 plus 1 whole square, that is 3 plus 2 root 2. We can simplify using a plus b whole square multiplied by capital R. Minus 2 times of root 2 plus 1 multiplied by small r is equal to right side, that is 2 times small r. To find the ratio, we'll take it to the right side. It can be written like this. This minus will become plus 2 root 2 plus 2 plus 2. So it will become 4 plus 2 root 2. And this is 3 plus 2 root 2. So capital R by small r is 4 plus 2 root 2 upon 3 plus 2 root 2. We can leave the result here, or we can simplify it further also. Because in this case, if you will see, this part is nothing but root 2 plus 1 whole square. So it can be written like that. And in this case, in this factor, in this numerator, we can take 2 root 2 common and we can write it 2 root 2 multiplied by root 2 plus 1. And root 2 plus 1 will get cancelled out. So this is 2 root 2 upon root 2 plus 1. And even we can simplify it further, multiplying and divide by root 2 minus 1. So if you will do that, denominator will come out to be 1. Numerator will come out to be 2 root 2 multiplied by root 2 minus 1, which is 2 root 2 multiplied by root 2, that is 4 minus 2 root 2. So the answer can be simplified in this way. So guys, if you can think of any other method of solving this question, feel free to share in the comments below. Thank you so much for watching this video, and I will see you in the next video.